This is a new lesson. We are going to be learning about exponents and writing in exponential notation form. And our first focus is going to be learning about the product of powers. So that'll make more sense here in a moment. But I wanted you to review integers. Now, we just talked about what an integer is. And an integer, again, remember it's the positive, whole numbers, and their opposites. So when we talk about integers, we're going to try to solve these without a calculator. Now, if you need your multiplication chart, some of you have these, some of you have lost theirs. I'm going to go ahead and leave a few on the desk so you can ask the sub. I'll just put it here by my post-it notes. So if you need to get one to keep, I am okay with that. I'm going to put a little stack here. All right, so we are going to solve without a calculator, or you can use your multiplication chart. That's fine. Pay attention to the signs. So for example, we have a positive 4 times positive 6. So what's 4 times 6? Well, that is 24. Here's what I want you to pay attention to the signs. It's a negative 8 times 7. Well, negative 8 times 7, if you had 7 of these and you're adding, it would be a negative 56. Okay. Now, negative 10 times a negative 6, a negative times a negative is a positive, and 10 times 6 is 60. We have here division, 54 divided by 9. Well, 54 divided by 9, what times 9 is 54? And that is 6. Negative 18 divided by 9, it's going to be a negative 2. And negative 48 divided by negative 6 is going to be a positive 8. So we're talking about the sign, so just, negatives, just a kind of a quick review about your multiplication with integers. I want to tell you about something. When you do 4 times 6, this is a faster way of saying 4 plus 4 plus 4 plus 4, 1, 2, 3, 4, plus 4 plus 4. You're saying you have 4 6 times. And that's a faster way to do repeated addition is multiplication. So repeated addition, faster way to do that is multiplication. Now this could also be 4 sixes. You can do 6 plus 6 plus 6 plus 6. And so repeated addition, a faster way to repeated addition is multiplication. Now, what happens when we have repeated multiplication? What is a faster, faster way to write 4 times 4 times 4 times 4 times 4 times 4 times 4? So this is repeated multiplication. So hopefully you remember from last year, maybe not, I can't remember when you guys are introduced to this, but what this is saying is that you have this number 4 how many times? 1, 2, 3, 4, 5, 6, 7. 4 7 times. Now notice I'm not going to write 4 times 7. This method is repeated addition. This is repeated multiplication. So when you have this little number up here, your 4 is called the base, and the 7 begins with an E. Hope you're thinking about it. It's called exponent. And you really want to write it this way and have a little, don't write it like 4, like 7 like that because it looks like 47. So get good about knowing, okay, that's an exponent. It's risen to the exponent here. Now this notation, when it's written in this notation, it's called exponential notation. Okay, so exponential notation. So when we have this 5 to the 4th power, it means 5 times 5 times 5 times 5. And then this one, this is 3/5 to the 3rd power. Now notice those parentheses, you're taking the entire base to the 3rd power. So you're saying 3/5 times 3/5 times 3/5. So what that means is that you're taking the numerator times itself 3 times and the denominator times itself 3 times. Don't change these fractions to decimals, okay? Now for the algebraic example, what this means is x to the nth power. So your x, whatever your base is, so remember this is your base, and that's your exponent. That means your base is multiplied however many times that n says it. So if it says, like this one, 4, there's a total of 4. Not this 5 first and then 4 more. It's a total of 4. If this was 3, there's a total of 3, 3/5. That's kind of hard to say. All right. So writing, all we're doing is writing an exponential notation practice. We are not solving. We're not really solving. You don't want to simplify. I don't care what 4 to the 4th is right now. So this is 4 times. So your base is 4, and your exponent's 4. Now watch this base. This is a -3. This is very, 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 very important. Notice those parentheses. The entire base, you need parentheses around this. And how many times do you have that? You have 3. Because when we get to, if we did this to the 4th power, that means something different than this. So if your whole base, if you want the whole -3, make sure you have parentheses around it, and you do. All right, so this one, well, how many -11 and 4500s do we have? We have 2. So keep that parentheses around that. When it's usually like decimals and negative integers, I go ahead and keep those parentheses if possible. This one, since it's positive, we have 12 to the 1, 2, 3, 4, 5th power. Now, x's, how many x's do we have? 1, 2, 3, 4, 5, 6. Notice it's all still multiplication. The only way you can write this, if it's repeated multiplication. Okay, what about this one? So we have a negative, ooh, wait a minute. Well, that's right. We still have a -3/4. How many times? 4. Okay. Now, we want to talk about something like this. Will these products be positive or negative? If we had to evaluate this out, if we had to do -1 12 times, if we wanted to say -1 times -1 times -1, I mean 12 times we can list this out. Would that be an answer of negative or positive 1? And we know it's going to be 1 because you're multiplying 1 by itself 12 times. So if you did this 12 times, what's that? 3, that's 6. Okay, if you did it 12 times, what's it going to be? But you can think already what it's going to be. So 2 negatives, when you multiply, make a positive. So that's positive, 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 positive. It's going to be positive. Okay. And what about this? -1 to the 13th power. So if we were to have 12 here, if I add one more, if this is all positive, one more -1 is going to make it negative. So the key, I hope you can tell, the key is your exponent. If you're dealing with a negative base and your exponent is an even number, it's going to be positive. If the exponent is an odd number and you're dealing with a negative base, it's going to be negative. Now, right now, we'll work with that. So if you're like, I have no idea what the heck she said. So here's the deal. Like this one, if we had to evaluate this out, 3 to the 3rd power, you have this on your cube sheet. That means 3 times 3 times 3, which is 27, but it's going to be a -27, okay, because there's 3 of them. This one, since there's going to be 4 of them, that would be a positive, what, 81 over 16 squared is 256. So anyway, look at my chart here. But that would be a positive answer. So let's look down here, fill in the blanks about whether the solution would be positive or negative. Well, if n, sorry, that whole bunch went through it, if n is a positive even number, that means the exponent. Okay, so if the exponent here is even, then this would be, if that's an even number, that's going to be a positive answer. If the n is a positive odd number, if that's odd and that's negative, the base is negative, it's going to be a negative number. You'll get more practice with that. Okay? All right. So let's look at this. Now we have this problem that we're taking 3 to the, I can't even see what that says, 3 to the 6th times 3 cubed. Okay, expanded notation means 3 to the 6th. That means 3, and you can do the multiplication sign, the dot, parentheses, I don't care. 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, 6. We have 6 3's multiplied by each other times 3 times 3 times 3, 3 cubed. So we have this 3, now notice it's multiplication, not addition. So we have 3 6s here, excuse me, 6 3s here, and 3 3s here. So exponential notation, how many, this is the base, all the same base, all the same number, but how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 to the 9th. Okay, so if we're doing 3 to the 6th times 3 to the 3rd, we can list it all out, and the exponential notation will be 3 to the 9th. What about this one? Now we have a -2. We need parentheses. And since it's parentheses, I'm going to go ahead and just put those side by side. I'm not even going to put a dot or x by it. That's -2 cubed times -2 squared. So that means we have 3 of them here, 2 of them here. How many total do we have? We have -2 to the 5th power. Now, see, hopefully you're starting to notice something. 5 times 5 times 5. I'm just changing up just so you can see it differently. Times, now be careful here. How many 5s do we have? We don't see an exponent. If you don't see an exponent at all, it's automatically assumed there's an exponent of 1. Okay, so then we have 1, 5. So how many total 5s are we multiplying? We have 4. Now, hopefully you're starting to see a pattern between where we started and where we ended. Look at our problem. Now it says product of powers, meaning we're multiplying all these. And hopefully you see here. So this is the fraction 5/8 squared times 5/8 squared. Hopefully you can go straight here and do your answer. But if not, let's write it out. 5/8 times 5/8 times 5/8 times 5/8. Now, how many 5/8 do we have? I'm going to do parentheses. You'll notice, and I'll show you why. Well, we have 4 of them. If you don't do parentheses and you just do this, that 4 is only attaching to the 5, not the whole thing. So make sure you have parentheses if the whole base is being one that's multiplied over and over again. Okay? All right. What did you notice about the starting problem here and the final exponential notation problem? What did you notice about the exponents, and what did you notice here? Hopefully you noticed that these exponents, and this the exponent, is that when you are multiplying by the same base, you add the exponents. And the same base is this, 3 and 3. So what did you notice? Hopefully you noticed that when you multiplied those bases, you could have just added the exponents. So in your own words, what could be the rule when you multiply powers at the same base? When you multiply powers at the same base, that's going to be important. Multiply powers by the same base, add the exponents. So let's, for example, that doesn't work. With this, let's say 3 to the 6th times 2 to the 5th. You cannot, it does not equal like 3 to the 11th or whatever. Don't add these. These two bases have to be the same. Okay? So when you're multiplying by the same powers with the same base, add the exponents. All right. So here, I would love for you to try this. Pause me, and then you can come back, do it yourself, and then check it. All right? So, in the meantime, I'm going to go ahead and do this, but pause me. 14 to the, what is that? Oh my gosh, you guys, I'm blind. 14 and 28. So what is that? Is that a 12? 2, 3, 4. 14 to the 42nd power. -3 to the 17th power. Now look, notice this letter, B to the 54th power. A to the 20, 15, and 15. 15 and 15 are 30, plus 20 is 50. 2, now be very careful here. A lot of people make, a lot of people make a mistake. This is 2 and this is 4. Oh, man. 2, 4, and 1. So we have 2, 4, and 1. There's a 1 here. So 6, 7. Don't let that trip you up. A lot of people miss that one. Oh, here's another one. 1 and 3, and that's 4. -2 and 4 tenths to the 4th, and 4 to the 10